MS Ramaya University of Applied Sciences.
Hello students, in this session of control system MATLAB videos, we will see how to design a lead and a lag compensator. First, let us consider a system and try to find the root locus of it. Then we will design the lead lag compensator for it. So consider a system G is equal to transfer function of, now I will define the numerator as 1 space 2. So 1 and 2 are the roots of the numerator. Now I will define the denominator as 1 space then 9 space 23 space 15. You can consider any transfer function. So now I have the transfer function s plus 2 divided by s cube plus 9s square plus 23s plus 15. Right. Now we will use a tool called as a SISO tool. So to invoke that tool, I write RL tool. Inside the tool we write the transfer function for which we want the root locus. So RL tool stands for root locus tool. So when I press enter, the SISO design tool will open up like this. So let me maximize. So this is the root locus for the given transfer function. I have one pole here, the second pole and the third pole here, and I have a 0 here. So this root locus has two branches which goes to infinity. Now let me arrange the axis properties. So I increase the limits of the real axis to minus 15 so that I can have a clear view of the root locus. So this is the root locus which I want. Now let us start designing the root locus or the system using lead and lag compensator so that we get the required parameters. So if I vary this pink cursor, then I can find out the gain at different points of this root locus. Right click. Now I will take a design requirement. So now I want to design the system such that I have a specific damping ratio. So I will select damping ratio. Select this damping ratio. So here it is 0.7071. Now I want a damping ratio of 0.6. So I'll type 0.6, click OK. Now, so this line shows the damping ratio 0.7, which means anywhere on this line the damping ratio will be 0.6. So the root locus crosses this line at this point, so therefore the damping ratio is 0.6. So anywhere on this line the damping ratio is 0.6. Now I will add another design requirement, which I will select it as the natural frequency omega. So initially it is 1. I will change it to say 8 radians per second. Click on OK. So you get a second line which looks like an ellipse. So anywhere on this point the natural frequency of oscillation is 8 radians per second. So this line and the second line intersect at this point. So at this point the natural frequency is 8 radians per second and the damping ratio is 0.6. But this root locus does not pass through this point. The root locus passes like this, where at this point it satisfies the damping ratio, at this point it satisfies the frequency or the natural frequency of oscillation. So it does not satisfy both the conditions. So I want the root locus to pass through the intersection of both the lines. So I want the root locus to pass through the intersection of both the lines. So what I will do, I will add a lead compensator. So right click, add polar 0, then select lead, click. Now I will place the lead compensator here. So observe what happened. The root locus has shifted more towards the left. I will arrange the placement of the pole such that the root locus passes through the intersection of this point. So therefore I can select my gain so that the root locus passes through this point and I get a system which has the design requirements. So this is the intersection point. Now let us see what is the transfer function of the lead compensator. So this is the transfer function of the lead compensator. So I want to view it in another form. So go to edit, seesaw tool preferences, click on that. Now go to options, then select the third option, zero pole gain. So I have the transfer function of the lead compensator in this form. So this is the numerator of the lead compensator, this is the denominator. So now I will delete this lead compensator and we will try to design a lag compensator. I will right click. So I delete this lead compensator. Now I go to design requirements and I add a new requirement which is the natural frequency or damping ratio. I select the damping ratio and I change. Initially it was 6 but now I change it to 0.4. Let us see what happens. So you get a third line which passes like this and your root locus passes through the line at one point, but I want it to cross through the intersection. So what I do, I select a lag compensator so that the root locus is shifted to the right. Now I want the root locus to shift to the right. So as you see, the root locus has shifted to the right, but I want it to pass through this point. So what I do, I shift the pole so that the root locus shifted slightly towards the left. Now you can see that the root locus has shifted to the left and is passing through the intersection point. You can also shift the 0 and adjust the root locus. So this is the root locus where it passes through this point. At this point, if I find the gain, then I can adjust the gain of the system such that it satisfies my design parameters. So here you can adjust all the design parameters. You can type various values and using a lead compensator or a lag compensator you can design any system to work and perform as per the required parameters. So this is the new lag compensator and this is the gain. So that's all. Thank you.
At MSR UAS, we spark your imagination unlike any other.